Okay, so let's get into it. So question 1, what is 1,560,200 kilometers written in scientific notation correct to two significant figures? So again, our strategy with any multiple choice question or any question in a maths exam is always going to be to start by highlighting any numbers that they give us, because they're not going to give us numbers and then we don't end up using them. And this makes sure we don't forget anything. So we've got that one, and also worded numbers like this 2 with the significant figures. That's going to be important as well. Now, if you've forgotten what scientific notation and significant figures meant, you could still probably figure this out just with a little bit of logic and luck. So starting with our two significant figures, all significant figures are is basically just numbers that aren't 0, in as simple terms as I can put it. So when we look at our 4 answers, you'll notice that 2 of these options, A and C, that decimal number out the front has 3 numbers that aren't 0. We've got 1, 5, and 6. The other 2 options, B and D, only have 2. Because we're talking about the options that have 2 significant figures, straight away we can knock off answer A and answer C, because they have 3 significant figures or 3 numbers involved. So now we're looking at B and D. The only difference between them is that power above the 10. And now timesing a number, usually a decimal, by 10 with a power, that's called scientific notation. And we usually use it to show numbers that are really, really big or really, really small in kind of like a quicker way. A lot in science, that's why it's called scientific notation. So if we start with this 1.6 times 10 to the 5. If I was to write that in scientific notation, I'm just going to write that number, 1.6, and basically I'm going to grab that decimal and move it down 5 spots. Okay, so it would end up there. And any of those empty buckets, I'm going to fill up with zeros. Okay, I know that I'm moving it to the right because that number should be getting really, really big. The only time I'd go the other way and move that decimal to the left to make the number really small is if I had a negative power. Okay, so you can see that number I end up with is 160,000. Now going back to the number that we're trying to write, that is clearly nowhere near. It needs to be a lot bigger. So we should know straight away that B is not correct. It must be answer D, but we can quickly prove that to you as well. So if we do 1.6 times 10 to the power of 6, we're going to start by writing it again, and this time we're going to grab that decimal, move it down 1, 2, 3, 4, 5, 6 spots. And again, we're just going to fill all those buckets up with zeros. And you can see, if I go, that's a group of 3, that's a group of 3, I end up with 1,600,000. Okay? And so answer D is just a simpler way of writing that 1,560,200 kilometers, because I've rounded it off to be basically 1.6 million, and writing in scientific notation saves me writing a ton of zeros out. Okay, so question 2 says, which of the following is 4x plus 3y minus x minus 5y in its simplest form? So if you're ever asked to do any simplifying with algebra, so whether it has x's, y's, a's, b's, anything like that, you're only allowed to combine things that are the same, like terms. Okay, so one way to really easily show that is either to underline or highlight all of the x's. So I've got 4x there, and I've got a minus x here. You always want to grab the symbol and the number that's in front. So while I'm at it, I've got 3y, it's positive, and minus 5y. So all I'm going to do is combine the things that are the same. So I'm going to start with my 4x minus x. Now you could do this on your fingers by holding up 4 and putting 1 down, or maybe you just type 4 minus 1 into your calculator if you're a bit stuck on that, and you'd end up with 3x. Now straight away you can see 2 of those multiple choice options that start with 5x can't possibly be right. So I'm going to knock those out. So now we'll do the y's. You can see I've got positive 3y. We don't tend to write the positive if it's at the start, but if you were to chuck a little plus here, there's no harm done. It's just going to be 3y. And then we're going to take away 5y. Now straight away you could realize we're taking a bigger number away from a smaller one, so we're going to end up negative, and you could jump straight to your answer and move on, save yourself 5 seconds on your exam. But if you aren't that quick, you could again use your fingers, type into your calculator 3 minus 5, and you realize you get minus 2y. So we end up with 3x minus 2y, which is answer A. So question 3, we've got Gail. Her gross pay each week is $952.25. Now I'm going to start by highlighting that number. I also like to pay attention when they talk about weeks, because that can often be a bit dangerous. They might start the question by mentioning weeks, and later down the track they might turn it into a year or a month containing 4 weeks. They often try to trick you with time. So just make sure that everything's in weeks and then we're all good. So as we go down, the following deductions. Now to deduct something is to take it away. So we're going to be minusing. Are taken from her gross pay each week. Okay, so again we're in weeks, so it's all good. We're basically going to start with our $952.25, and we're just going to take away each of these deductions. So the way I'd be doing this is I would just be on my calculator typing it all in on one line. You can do it in separate steps if you like. The only important thing here is make sure that you pay attention to the buttons that you're pressing. You don't panic and you don't accidentally put a wrong number in or a decimal in the wrong spot, because that would just cost you an easy question. So we're going to take away 180.93, 85.7, 21.4, and finally that 38.15. Hit equals, you should get 626.07, and beautiful, that's my answer. Now if you had, I don't know, put a decimal in the wrong spot, or you had a number that wasn't slightly right for whatever reason, you could have a look at what yours is closest to if it was a tiny mistake. Otherwise I'd take the minute to just quickly go back through and do that question again. Question 4. So on a school report, a student's record of completing homework is graded using the following codes. And it wants to know what type of data is this. Okay, so this is basically a literacy question. It's just making sure that you understand what these words mean. Now straight away, I'd start with these bottom two, where it has quantitative data, which is a word I really struggle with. Now quantitative data, that starting word sounds a lot like quantity, and that's actually where it comes from. Okay, so a quantity of sour worms, for example, is how many sour worms you have. So it's a number. So when we have numerical data, we call it quantitative data. In this case, we're talking about a code using words, so it's clearly not going to be quantitative. For interest's sake, while we're here, these two words afterwards are different types of quantitative data. So when we're talking about numbers, the first one here, discrete, that's talking about whole numbers or integers. So for example, if you're measuring like temperature this week, and it was 12 degrees, and then 15 degrees and 13 degrees, they're all whole numbers that we use. Okay, so that's discrete numerical or quantitative data. Continuous data is just the other type. So it includes all numbers. So it's often used in measuring. So if you were measuring rainfall or students' heights, you're not going to have only exact nice numbers. You can have those decimals in between. So that's continuous numerical or quantitative data. So we're down to two options. We've got categorical ordinal or categorical nominal. Now try and find one of these words out of ordinal and nominal that sounds similar to something you already know. For me, with ordinal, that sounds a lot like order. And again, that's like where these words actually come from. So if my data could be put in order, I would call it categorical ordinal data. Now you can see that we're using a scale that's grading them, where a C is clearly going to be better than an N. Okay, so we can put it in order, and it's already in order, so we call it categorical ordinal data. Nominal data is just, again, categories, so words that we can't put in order.